Welcome to solverfy.
In this question, we have given that a chandelier is 5 foot length and it's hanging in the ceiling, which is 35 foot above, and it is given that, let's say, a man 6 feet tall is standing right directly under the chandelier. So let's say that the chandelier C and it's of the height 5 feet. So this is 5 foot, and the man exactly stands right here, who is 6 feet tall, and the distance here it is going to be 35 foot. So for the first subdivision we have to calculate is how long do you have to get out of the way so that the chandelier does not fall on the head of the man. So for that, let's say that this is going to be the total one, that is y subtracted by y naught is going to be the total foot, that is 35 subtracted by height of the man plus the chandelier height. So it's going to be 35 subtracted by 11, which is y negative of y naught is going to be 24. So v of 0, that is the initial velocity, is 0, and here the gravity acts, so it is going to be 32. So after this, let's form the equation which states that y is equals to y of 0, that is y naught, is equals to plus v of 0 multiplied by the time subtracted by 1 over 2 gt squared. So let's say y subtracted by y naught is equals to v naught is 0, so 0 multiplied by t is going to be 0, negative of 1 over 2 32 multiplied by t squared. So y subtracted by y naught is 24 is equals to negative 1 over 2 multiplied by 32 into t squared. So simplifying this, we'll be having 16 right here. So t squared is equals to 24 over 16, that is in the negative 1. So here the gravity is in the negative form as it's falling downwards, so this sum becomes plus. So this implies t is equals to square root of 24 over 16. So upon simplification we get t is equals to 1.22 seconds, which is the required answer. So in the next subdivision, it is said that we have to find the speed at which the chandelier travels if we haven't moved from that given point. So for that, let's say that speed is equals to v of 0 the whole squared plus 2 times of gravity g multiplied by y subtracted by y naught. So this is going to be 2g y subtracted by y naught. So 2 times of 32 y subtracted by y naught, which is given as 24. So 2 subtracted by 32 multiplied by 24. So this is going to be 1536. As it is s squared, we'll have s is equals to square root of 1536, which implies speed is going to be 39.2 feet per second. So this is the required speed. So moving on, the third subdivision is to find if we have only 5 feet height. So we are assumed that we are in 6 feet height. So what happens if the man is 5 feet height? So then the height will be changed to 30 subtracted by 5 that is going to be 25 feet. Therefore, speed will be changed, which is going to be square root of 2 multiplied by g multiplied by, and this is 25, there we had 24. So this is going to be 2 multiplied by 32 multiplied by 25. So square root of, this is going to be 1600. So square root of 1600 is going to be 40 feet per second. So this has to be subtracted by this speed. So the original speed, let's give OS as 40 subtracted by 39.2, which is going to be 0.8 feet per second, and the required answer is obtained.